What I'm going to cover in this topic is how Unix handles programs processes. Before I explain on how Unix handles Unix programs or processes, let me compare this with Windows. We might have noticed when we work on Windows, if something does not respond, for example, we are playing a movie or we are working on a notepad or a word pad which is not responding. When when you are trying to close it, it's not getting closed. It's just saying that hourglass completely rotates forever. We wait for like a minute or 2 minutes or 5 minutes and still it does not respond. What do? We press Ctrl or Delete and we'll go to the task manager and we'll find out a respective program and we kill it. In short, we highlight the program and we click on End Program, right? Agree? So what we indirectly doing there is the program we are identifying in the task menu and we are highlighting it. The moment I say End Program, we are killing that program. Indirectly killing, not indirectly, we are directly only we are killing that program. Now what that means is there are two important terminologies here. One is program, another one is process. Any one of you tell me what is a program and what is a process and what is the difference between both of them?
Program is a task.
Uh-huh.
Yes. Program is a task for a computer to execute something for producing a result,
Very good.
which is required by the user, and the process is the time taken to compile that program by the processor or the operating system using the hardware.
Kaushik, so Hama says executing program is a process, right? A program is nothing but a sequence of instructions. It can be anything. A sequence of instructions like addition of a program, a sequence of instructions like running a movie, a sequence of instructions like cutting and pasting somewhere. Anything. When I really do that program, it becomes process. One example I can tell you here is if I open our environment here. There is a command that we looked at in previous sessions, that sleep. What is sleep does here is, to quickly repeat, it halts the execution for the number of seconds I specified here. If I specify 4, it halts the execution for 4 seconds. Sleep is an executable here. Like when I say ls lists the files, right? But to find out from where we are getting this ls command, I simply have to do which ls. Now this is a program to me. This is a program to Unix. This is a program to you. Nothing but this ls has a sequence of instructions. This is a binary 64-bit executable and this has sequence of instructions. Similarly, when I say which sleep, this has a sequence of instructions. Sometimes you can read it, sometimes you may not be able to read it. However, when I run this program by giving some input, when this is executing this becomes process. So the fundamental difference between program and process is program is nothing but a sequence of instructions. You can call it as a task. A process is nothing but this program in execution is called a process. One more example I'll tell you here is Let's say a recent movie released and you went into your friend's room and you copied that movie in a pen drive and you stored that movie in one of your local drives. Why do you copy the movie into your local drives? So that you can watch it in your free time. The moment it stays in your local drive, it's a program because it's not consuming any resources other than disk space. Agree? There are four fundamental things from resourcing point of view. The first one is CPU, second one is main memory, first one is CPU, second one is main memory, you call it as a RAM, you call it as a physical memory, third one is storage or a disk, fourth one is network. These four resources play a crucial role in execution or performance of anything. Now when I talk about a program just occupies space here. Let's say you just simply store a movie in a like M drive or a D drive or S drive. But when you really want to see the movie, what would you do? You right click that movie and you play using Windows Media Player or VLC Media Player, you name it. Now what happens at the time is, the moment I am trying to store this or run this movie, data is copied from storage or disk to main memory. On this main memory only, your CPU works. So data will be streamed from the storage or disks to main memory. On this main memory, CPU works. Now, the moment this happens, this is nothing but a process. That's what happening here. The moment I say sleep, when I say which sleep, this is an executable here. The moment I say here sleep 20, even I can run sleep from here. Two things I can execute simultaneously. Now what happens when I run sleep in the background is, the sleep becomes a process. Now the important thing in Unix is how do I see these processes? On Windows I can simply click Ctrl Alt Delete, I can go to Task Manager and I can see it under the Process tab. But how can I see these processes in Unix? The command here is ps. ps is a command that will show me by default the processes started from the current terminal, this terminal. From this terminal, what are all the processes that got started? Now let me start it again. Now in processes, there are two types of processes. One, the processes that we start, user processes, the processes that system starts. So when I say PS, it will by default show me the processes that started from this current terminal. Whereas when I say PS-AF, it will show me the processes started by this user ID. Whatever is the current user ID talking about, it will show me the processes started. You look at this, there is someone running sleep 100 command. The command is sleep 100 here, which is started on a terminal 0. And the process ID for this is 31438. Each process will have one unique ID, 31438. And if you look at the parent process ID that started at 31045, like we all have parents, even the process has a parent. Now this parent again has a parent. Now when I do ps-ef, AF will show me all the user processes. EF will show me both user and system processes. When I run ps-ef, the output will go in more than one place. It's a big out. So the command to see user processes is ps-af. System processes is ps-ef. In fact, it's not only system processes, -ef shows all processes. When I run here sleep 200 seconds, sleep or halt the execution on this terminal for 200 seconds. I can come here and I can see. When I say ps-ef, I can see it here. Sleep 200. When I say ps-ef, when I grep for sleep, we learned the grep command in previous session, right? What does grep do? Grep is like Control F in Notepad. In a notepad or a word pad, if you want to search for something, what would you do? You just say Control F and you just type the string. Similarly, in the given output that's coming from ps-ef, when you use the pipe symbol, the output from this command is given as input, this grep. In each and every line, grep goes line by line and searches for the word called sleep. It will give you that db2inst1 is the user who started it. The process ID for this is 31504. The parent process ID who started this guy is 31045. I'm not sure what is the 0 means, but this is when it started on this terminal. So far it executed this much time. Sleep 200. I mean this. Now if I want to find out what is this 31045, just grab for the same thing. When I say 31045, it is started by 31044, right? Even this parent has a parent, right? Now when I search for this guy, ps-ef grep for 31044, 44 is started by 35. The chain goes like this. Like our parents has a grandparents, we have a grandparent to grandparent, like that. 31035 started by 1835. Finally, all these will route to 1. 1 is nothing but your earlier ancestor you can find. When Unix starts, the first process that starts is 1. That's why when I say ps-ef more 1, the first one is 0. 0 does the initialization of entire system. Then 0 starts 1 and 0 is also starting 2 here. Now all these 2's are starting various child processes. The whole concept in processes you find is parent and child. You have a parent, parent starts a process. Any questions so far?